So in this question, I have a tank containing 11 grams of chlorine gas at a temperature of 82 degrees Celsius and an absolute pressure of 5.6 times 10 power 5 Pascal. The mass per mole of chlorine is 70.9 grams per mole. We want to find the volume of the tank. So this is like a straightforward application of the ideal gas law. We want to find the volume. So using the equation PV equals nRT and rearranging for the volume, we have V equals nRT over P. So we don't have the number of moles, rather we are given the mass and the mass per mole, or what we call the molar mass. So I will substitute the number of moles by the mass over the molar mass, and the rest is basically just some numerical substitution. Remember to convert the unit to Kelvin. I didn't convert the mass and the molar mass to kilograms because the units are just gonna cancel out on the numerator for the mass and the denominator for the molar mass. So calculating this, we get 8.17 times 10 power minus 4 meters cubed. In part B, we want to check what happens when the temperature of the tank drops to 31 degrees Celsius and a leak occurs, and the pressure then drops to 3.8 times 10 power 5 Pascal. We want to see how many grams of chlorine gas have leaked out of the tank. So seeing the pressure and having a new temperature, we can calculate the number of moles and find the mass that we have inside the tank. And then we can check how much has leaked out of the tank by just subtracting from the initial mass, which is 11 grams. So I'm gonna solve for the number of moles before I start. This can be written as PV over RT. And then the mass in the tank can be written as the molar mass times P times V over RT. So we can also then, this is the mass that we have in the tank. Whereas we can write the mass remaining, the mass leaking actually, because that's what the question is asking us for. So this is going to be 11 grams minus the mass that we have in the tank already. I'm gonna leave the molar mass in grams again because I have left the mass here and 11 grams as well for the total mass of the gas. So again, the molar mass is 70.9. The pressure now is 3.8 times 10 power 5. And the volume is essentially the same because we have a tank, so it is rigid and it will not change in volume. The temperature is now 31. And again, don't forget to convert to Kelvin. So if you calculate this, you will find the mass of the gas that has leaked outside is 2.3 grams.